All right, sorry, I had to figure out my internet problem after this. All right, so we have, let's pull up the calculator. I'm mental mathing this, but let's make sure we're doing this correctly. So 56 times 7 is 392. So the remainder is 6. That's good. That's good. That's probably correct. So if we rotate 1, 2, 3, 4, 5, 6, 7 6 times, we get, it's going to be, so let's just do it in order. 7, 1, 2, 3, 4, 5, 6. 6, 7, 1, 2, 3, 4, 5. I know this is tedious. Just stick with me. 5, 6, 7, 1, 2, 3, 4. And then it's going to be 4, 5, 6, 7, 1, 1, 2, 3. So that's 4 rotations. And then it's going to be 3, 4, 5, 6, 7, 1, 2. So that's 5 rotations. And the final rotation should be 2, 3, 4, 5, 6, 7, 1. Now, what was the result supposed to have been? 2, 3, 4, 5, 6, 7, 1. Guess what? That's the answer. So remember earlier again, we talked about, if we subdivide it by the number of full rotations, we actually don't need to rotate it that many times. We just need to basically rotate it by the remainder of the number of times the rotations are divisible by the length of the list. So how can we fix our immutable solution to do this? Well, what we're going to do is we're going to take k. So and again, naming is hard. Let quotient k equal to k modulus nums dot length. So if we do this, we basically will subdivide it, and then everywhere we've got, and I probably could have made a shorter name, everywhere we've got k, we're going to leave it, everywhere you've got k, you're going to replace it with quotient k, which in this case is only 2 places. So let's delete all this stuff, otherwise the test case is not going to work. What I'm postulating is that we should get the right console log answer if we run this. So let's run the test case. And that's not, I have too many console logs. Okay, so let's look at the first console log. So the first console log should be the start array and the end array. So we get, let me check my console log again. So it's going to be start array and then end array. So it should be 2 distinct arrays. So that's this one right here. So the start array is, that's not what I expected. So it basically put the entire list into the first. So what have we done wrong? Let's console log quotient k real quick to make sure that we're on the right track. All right. 6. That's not, is that correct? We said r is equal to 6, right? I think that's correct. Okay, so quotient k is correct. So that's what we expect. So now let's go back and look at this. So we're saying we want to slice it up to this and reverse it, end array. So if I go to 6 plus 1, that's 7. So why is it, that's interesting. Why is start array the entire length of the list? That's for fun. Let's go off by 1. Oh, I'm looking at the wrong one. I'm so sorry, everyone. I was looking at the wrong console log. So if we revert that, yeah, we get, no, that's still wrong. Huh. Why does that not work as expected? I would expect that to have worked. So it should be 7. So k modulus 7. So if we divide 398 by 7, we get 56.8. So all right, let's do this real quick, everyone. I apologize. I was expecting this to work, and it's not quite working the way I imagined. So let's look at the modulus real quick. So if we run the code, we should get started right. So that's 6, which should be the remainder. So that's correct. So the question, again, we're trying to figure out right now is that why, when we're doing the slice, it's going to be 6 plus 1, which is 7. So it's going to copy everything from 0 to 6 and reverse it, which is what we expect. So that's correct. So that's interesting. What am I doing wrong? So I think it's off by 1. I think it's supposed to be actually -1. Because when we do that, we get 2 distinct arrays of 6, 5, 4, 3, 2, 1, and 7. And you reverse both. And we reverse it. Okay. So new array is... we really don't need this because we're just giving the same answer twice because we're just debugging in this case, right? Because we're just trying to test the immutable solution in this case. So I get 7, 1, 2, 3. So that's completely wrong. Okay, so we're still wrong. All right. So in this case, now that we're almost an hour in, let's look at a solution and then come back tomorrow or Thursday and see if we can get the right solution. So we're going to go to discussion. We're going to go to JavaScript. Okay, so this is a 2-point solution. That's not what I was looking for. I'm guessing... Let's try this one right here. Okay, so yeah, this is what I was trying to do. So in this case, okay, this is too complicated. I would not use dot entries in this. So I'm going to skip the solution because I don't think this is quite what I'm looking for. So let's try again. This is also too complicated in my opinion. All right, so let's sort by, and this doesn't always get you the right answer, but let's sort by num votes and see if we can get something that makes sense. Okay, so yeah, this is kind of closer to what I was expecting. So what they've done here is they've written a custom reverse function. And the reason they've written this is that they want it to be in place. So you can't use .reverse because it's going to return, I believe, and let's check this. I want to say reverse returns you a shallow copy, but it might be in place. Let's see. Yeah, so it is in place. I'm wrong. Okay, so I guess they did this because they just wanted to show how they could do reverse. But this is essentially logically, effectively what a .reverse does under the hood for the API. So the way the reverse function works is basically it's using what's called 2-pointers. So we've used 2-pointer in problems before, but they're setting 2 pointers where the first pointer is going to be the start of the list. And the second pointer is going to be basically wherever you're pointing to in the list to do the rotation. So in this case, it was k+1, right? That's what we were trying to do. So this solution is a little different than what I was trying to do because what they're doing here is they start by, okay, so this is just backwards. So they reverse the list first, then they reverse the front, then they reverse the back. But it's the same thing, right? It should be the same thing. You can reverse the front and the back and then reverse the entire list and you'll get the same result, I believe. And we'll prove that tomorrow when we try it again. So it looks like we were on the right track with the slicing and the subdividing. In this case, they're using k-1 because they're not using slicing, so they actually want to get up to the one before. So that's as expected, and this is as expected. So it looks like the key part that we missed for today was just writing a custom reverser and then passing them through. So let's stop for today. I'll sleep on this. I'm not going to look at this again. We'll come back tomorrow and stream again, and we'll try to solve this again without looking at the solution and solve it in place. Just to kind of talk about where we got through today. So we basically forgot to read the comment, although I'm looking at this right now, and it doesn't. So this is the problem with some Leetcode problems. It didn't say that it has to be, oops, I didn't mean to favorite it. It didn't say it had to be in place. Now, in place has memory advantages. It can be done, but you'll notice there is no requirement, but the problem itself says it has to be in place. So I would have liked if Leetcode in this place would have said, hey, it has to be done in place or you fail. But my bad. I didn't read the JS doc comments to see what the result should have been. So we'll definitely be more careful about that in the future. So the solution we came up with that won't work because it's an in-place one was we used array.slice to make a copy of the front half of the list and the back half of the list. We reversed them. We joined them into a new array using object or array spread, and then we reversed it. So next time, we will show the in-place solution from scratch without looking at help. All right, that's going to be it for the stream tonight. Thanks so much, everyone, and best of luck learning algorithms in your coding journey. Bye-bye.